Have you ever wondered how military aircraft can stay in the air for what seems like forever? Well, there's a secret that completely rewrites the rules of air power, and it happens thousands of feet above our heads, totally out of sight. Today, we're talking about gas stations in the sky, and trust me, they are way more important than you probably think. Right, let's start with this. How does a fighter jet fly for 12 hours without ever touching the ground? It seems impossible, right? You see one of these things zip past and you just assume its biggest limit is its fuel tank. But what if it wasn't? What if it could just, top up while it's still flying? Well, that's exactly what aerial refueling makes possible. So here's our game plan. First, we'll get into the basics of how these flying gas stations actually work. Then, we're going to look at the two big competing ways they get the job done. After that, we'll uncover a huge problem that's forcing everyone to rethink their strategy. And finally, we'll get to the really cool stuff, the automated and kinda revolutionary new planes that are about to change everything. All right, let's dive right into Section 1, Gas Stations in the Sky. This is all about the incredible art of the mid-air top-up. So, at its heart, aerial refueling is, well, it's pretty much what it sounds like. You've got a big tanker plane passing fuel to another plane while they're both cruising at hundreds of miles per hour. But this simple-sounding act has absolutely massive consequences. It means an aircraft's range is suddenly limited by its crew, not its fuel tank. This is exactly why military planners have a special name for it, a force multiplier. It's not just about flying farther. Think about it for a sec. A fighter can take off with less fuel but way more weapons, and then just fill up once it's airborne. Or a surveillance plane can just hang out over a hotspot for hours and hours instead of just minutes. It completely changes the whole chessboard of air power. Okay, so how does this whole crazy aerial ballet actually work? Well, there are two main ways to do it, and the differences between them are honestly pretty fascinating. First up, we've got the flying boom. This is the US Air Force's favorite. It uses this big, rigid, telescoping tube that comes out of the back of the tanker. And what's really wild is that there's a person on the tanker, a boom operator, who literally flies the boom using a set of little wings on it, guiding it right into a tiny little port on the other plane. And the power of this system is just unreal. The boom can pump fuel at an insane rate, up to 1,000 gallons every single minute. I mean, to put that into perspective, that's like filling up the gas tanks of 60 cars in 60 seconds. It's just a fire hose of fuel. Now, the other method is called probe-and-drogue, and it's a totally different approach. Instead of a stiff boom, the tanker just trails this long, flexible hose with a basket on the end, called a drogue. And here, all the responsibility flips. The pilot of the plane that needs gas has to do this incredibly delicate dance of flying their jet's little probe right into that moving basket. So you can see there's a real difference in philosophy here. The boom is super fast, it's controlled by the tanker, and it's perfect for gassing up one huge plane at a time, like a bomber. Probe-and-drogue, on the other hand, is slower. The pilot is in charge of the connection, and you can refuel several smaller jets at once, which is why the Navy, the Marines, and most of our NATO allies love it. But, and this is a big but, this incredible capability comes with a huge, glaring problem. For decades, these tankers have just flown around like support vehicles, way behind the front lines. But in a modern conflict, in what they call contested airspace, what happens when the gas station itself becomes the #1 target? And you can really see that shift on this timeline. After World War II, tankers were safe, no big deal. During the Cold War, they became these super important strategic assets. But now, the game has changed. The future is going to demand tankers that can actually survive in really dangerous skies. This threat is forcing a technological revolution. And what's the first step? Well, it's taking the human out of the most dangerous and difficult parts of the process, all through automation. And that brings us to A3R, or automatic air-to-air refueling. Now, this isn't science fiction, this is happening right now. These systems just got certified, and they use computer vision to let the tanker lock on and connect the boom all by itself. It makes the whole thing faster, a whole lot safer, and way more reliable, especially if it's dark or the weather is terrible. So the next logical step is to just take the human out of the plane entirely. And for that, meet the MQ-25 Stingray. This is the US Navy's first ever tanker drone that can operate from an aircraft carrier. It's supposed to be ready around 2027, and its whole job is to launch off the carrier and refuel fighter jets, which will massively boost their range and, maybe just as important, it frees up those super expensive fighter jets from having to do that job themselves. But automation is just part of the story. The most radical change is coming to the actual shape of the aircraft. We're talking about completely reinventing the tanker and moving way beyond that classic tube and wings design we're all used to.
Yeah, to survive in the future, the answer isn't just to build a slightly better version of what we have now. It requires a total, fundamental rethink of what a giant aircraft can even be.
Okay, let's just compare the current workhorse, the KC-46, with this radical new concept from a company called Jet Zero. Now, first thing, look at the max fuel capacity. They're pretty close, right? But now look at the efficiency change. The Jet Zero design is projected to burn 50% less fuel, and that creates a really fascinating situation. It's something called the efficiency paradox. Even though the new plane carries a little bit less fuel overall, it's so much more efficient flying through the air that it has way more fuel left over to actually give to other planes. So it's not about how much fuel you can carry, it's about how much you can deliver. And this chart just lays it out perfectly. To fly the exact same mission and deliver the exact same amount of fuel at the same distance, the Jet Zero plane would burn half the gas just getting there and back. That's not an upgrade. That is a revolutionary leap forward. So how does it do it? Well, the advantage comes from its very design. In a blended wing body, the whole plane is basically one giant wing, so it generates lift way more efficiently. The shape is also naturally stealthier, and by putting the engines on top, you shield its heat signature and its noise from any sensors down on the ground. And maybe the most important part, it's designed to fit in the same hangars we have today, which is a huge deal. And we might get to see it fly pretty soon, with testing for a demonstrator scheduled for 2027. Which really leaves us with this one big final question. As these flying gas stations become autonomous, more efficient, and tough enough to get closer to the fight, are we literally watching the whole concept of range just disappear as a meaningful limit in air warfare? It really seems like the sky is, quite literally, no longer the limit.